Hello everyone, welcome to my YouTube channel Easy Programming. I am Naveen Mishra and I'll keep on teaching you how to write programs in C language. In my previous videos, I have told you about loops, arrays and wrote some programs related to array but left some for you guys. I'll do some programs related to array, some important programs like searching and sorting. So let's start with searching first. So what is the searching? Let's say I have an elements in an array of 5, for example 10, 20, 30, 40, 50, and we want to know the position of a particular element like 30 is placed at third location. Then it is called a searching. Or searching an element like 35 which does not exist in the given list is called searching. So what is searching? Finding the element in the list is searching. The element to be searched is called the item. Whatever element you want to search, let's say 30 or 35, it will be stored inside item variable. So item is used. To search in the given list, you have two types of searching techniques. One is linear search and another is binary search. Okay. Linear search is an easier method to search and searches the element sequentially until the element is found or list is empty. Whereas binary search is a divide and conquer method to search the element. So you can use any one of these techniques, linear search or binary search, but based on your requirement, you can pick linear search or binary search. Binary search is a faster technique as compared to linear search, which is slow technique, but is capable of finding an element in the sorted as well as unsorted list. So let's hear about the difference between these two. So this is the difference. Linear search to search an element in an array using linear search, your array, there is no condition whether the array is sorted or not, but binary search can only be applied to sorted list only. It is easy to implement and understand, whereas binary search comparatively difficult. It takes time as every element is compared, so it is a slow searching technique, whereas binary search is a faster method to search. It takes more time to find the element, so time complexity is higher, whereas in binary search time complexity is lesser. Linear search is good if you have small set of elements like 5 or 10 and your list is sorted or unsorted, doesn't matter. Then you can use linear search. But for large set of elements it is better to use binary search, but make sure that the list is in a sorted order, that is in ascending or descending order. It is also called sequential search technique, whereas binary search is called divide and conquer method. If we think practically, then linear search is like finding something in a garbage bin. Suppose you have lost your ring and you searches the ring. You go to your dustbin and search there. Now there's the luck that matters. That if you are lucky enough, then the ring is in the top of the bin. And if you are not, you have to search the whole dustbin and so on. So it will take, there is no particular pattern how you would search a particular element. You have to go sequentially one by one until you find an element or your list is empty. Whereas binary search is finding a page number in the book. For example, in a book we want to reach to page number 250. You do not go one by one at one page at a time, like 1, 2, 3. You simply find a page, then compares the page number with the page number that you want to go, and then decides whether to go to the right direction or to the left direction. Okay, so to implement linear search you do not need any extra variable, whereas to implement binary search you need some extra variables like beginning and middle of variables. Okay, in linear search, to move from one element to the next element, you increment your loop variable I by 1 until the list is found, element is found or list ends. Whereas in binary search we calculate mid using this formula, that is beginning plus n divided by 2. Then compare the mid value of the array with the item to search and continue this until your list element is found or your beginning is greater than end. Okay, now let's implement this program working of linear search. So I have written some part here and we'll try to implement it in the program. Now simply I have declared some variables, I for loop, that is iteration, a5 elements of 5, and item is the element to search. Here I have asked the user to enter 5 elements in the array, then placed a loop in which I placed a scanf function using which the elements are placed. After inputting the elements, I ask the user to enter the element that they want to search, which is called an item. And once the item is received by me, then I'll put it inside a loop and keep on comparing with the item with the array element until the element is found or the list is empty. Now if your element is in the list, then this if will hit somewhere and it will print the location and the location of the element. Once I have found the element, I don't want to continue the search, so I'll put a break statement and stop the execution of my program. But if your element does not exist, then this part will never hit and your loop executes fully from 0 to 4, and when I becomes 5, the loop will stop. At the end of the loop, I'll compare that if I is equals to 5, it means I cannot find my element, so element does not exist. Now let's write this program. Just a second. C++. So I have written this program and I'll put it just inside the main function for you guys. So I'll place a header file here, include stdio.h, sorry for that. Then I put a main function and I'll put everything inside the main function and just place a return. Program was saved already. I'll just give the program a title. So program to implement the linear search. I'll save it and I'll compile and run my program. My program runs successfully. So let's input 5 elements in the array. First of all, I will enter elements in a sorted order. So 10, 20, oh sorry, 20, 30, 40, 50. I'll search an element like 40, and there you go. Element is found and placed at third location. Third location is there because I start from 0, so this is the 0th location, this is the first location, this is the second location, and so on, third location. So 40 is at third location. And if I put an element which does not exist in the list like 10, 20, 30, 40, 50, and I say 60, then element does not exist message is shown to me. I can try to put an element in an unsorted order as well. It will do the same thing like 20, 25, 6, 12, 3, and I'll search 60. It says element does not exist. Or if I compile my program like this one, 22, I'll say 45. Element is found and placed at second location. Now you might be thinking that why this 45 number was not printed, because I have put a break statement that if the element matches, then print the location and break. So after this 45 is matched with my item 45, the loop stops. Okay, so this is a program of linear search. Now linear search is suitable and good for small set of elements, but what if you have large set of elements like 500 or 600? Then you can use binary search. So this is the program I have done in binary search. To implement the program in binary search, you will read the value from user in the same way, you will ask the item in the same way, but to implement the binary search we need a while loop. Okay, we'll have a beginning, that is starting index 0, and the end, that is ending index like 4, and continue the loop as long as beginning is less than end. If the element exists in the list, then this point will hit somewhere and an element will be placed. But if I do not have the element in the list, then beginning at some point will be greater than end, and in such case this loop will stop and this 22nd and 23rd lines will get executed. Okay, let me show the working of this program to you guys. Here's the binary search. Okay, I'll do the same thing. Program to find the element using binary search. I'll put a header file here, hash include stdio.h, put a main function here, and I'll end this main function at the end. I'll put a return 0 statement here, and I made a mistake here. I think I should place a equals to here. Let's see. Now make sure your elements are placed in a sorted order. Okay, so let's compile and run my program. Okay, just square bracket missing here. Compile and run. Okay, bracket was extra. Compile and run again. and let's put 5 elements in the list. 10, 20, 30, 40, 50, and I'll search an element like 40. 40 is found and placed at 5 location. Why is that? Let me check. I'm printing an I, so just a second, I have to print mid value here. Okay, I'll compile and run my program, and I'll put 5 elements in the list like 10, 20, 30, 40, 50. I'll search 40, and there you go, element is found and placed at 4th location. And if I compile and run my program again, I'll put an element 10, 20, 30, 40, 50, let's say 10. Element is found and placed at 0 location. It still works fine. Let me compile and run my program again, and I'll put 10, 20, 30, 40, 50, and I'll try to search 60. Element does not exist. It still works fine, but make sure that you do not place the elements in a sort you do not place the elements in unsorted order. Like, you cannot do this, your program will not work. Okay, if you search an element 30, it will not work. Sometimes it may not, but it's better to put an elements in a sorted list. Okay, so this is a binary search. Now you guys will ask that what if my elements are not sorted? What if my elements are not sorted and the user places the elements in unsorted order? So you can implement sorting for that purpose. So let's start with sorting. What is the sorting? Finding a particular element in the given list is called sorting. Rearranging a given set of elements in ascending or descending order, right? There are different sorting techniques. Most popular of them are bubble sort, selection sort, insertion sort, quick sort, merge sort, heap sort, and shell sort. Okay, bubble sort is the slowest but easiest to implement and understand, whereas the fastest sorting techniques are quick sort and merge sort. I'll write a program for you guys for bubble sort. Okay, so let's see this bubble sort program. First of all, let's understand how the bubble sort work. So first of all, it is the easiest sorting technique. Then it works in passes and steps. So bubble sort will compare the elements one by one. So first pass, second pass, and third pass, and so on. If there are n elements in the list, it will take n minus 1 passes to sort the list, and at the end of each pass, the largest number in the list is placed at the end of the list. Okay, then it continues the next pass with n minus 1 elements. In pass, it performs comparisons step by step. It compares the first two elements and swaps their position. The first element is greater than second, okay, otherwise not. To implement the bubble sort, you need two loops. One is for pass and one is for steps. Okay. In the steps loop, you will compare your first and second element, and if first element is greater than second, you will swap their positions, and so on. You will continue this step until your list is sorted. Okay. The time complexity of a bubble sort is O(n) square. The time complexity, how that this time complexity is calculated, or what is O(n) square, for this you guys must know about data structures, and you must know about the time complexities, big O notations, and others. So I'll not continue these topics. I'll not teach you these topics here. Let me write the program for you guys. So this is the program that I have written already, and I'll write do it for you guys in the day. So what I have done here is, first 4 lines I have read the values, 5 elements from the user. Okay, after reading the values, I have put this loop to sort the elements. The first loop is for passes, the next loop is for steps. In the steps loop, my elements will keep on decremented by 1. So in pass 1 there will be 5 elements, in pass 2 there will be 4 elements, in pass 3 there will be 3 elements, in pass 2 there will be 2 elements, and so on. To do this, I have placed a condition like this one: 5 minus I minus 1. So initially I is set to 0, so 5 minus 0 minus 1 equals to 4. So j less than 4. First in pass 1, 0 to 4 loop will continue. Next time I will be set to 1, so 5 minus 1 minus 1, that is 3, and so on the loop will continue. Inside this steps loop, I have compared my element a of j with a of j plus 1, and if this condition is true, I have to swap these values. And to swap these values, I have placed a temporary variable temp declared here and used it to swap. Okay, so after swapping, I will end everything and will print the loop at the end of the and this will print me the elements in a sorted order. So let's work this thing. I'll open bubble sort here, and there it is. So I'll put it just inside the header files. Just a second. Program to sort the element using bubble hash include here.h main function will be there. I'll put curly braces and put everything inside the curly braces. I'll put a return 0 here as well. Let's me compile and run the program. So let's me I put the 5 elements in unsorted order: 50, 60, 20, 10, 30. Okay, just a second. Is there something problem? Okay, j is equals to 0, j less than 5 minus I minus 1, aj greater than aj plus 1, temp is equals to aj. Okay, I should have placed here. And let me compile and run my program again. So 20, 50, 60, 10, 30. There you go, 10, 20, 30, 50, 60. The list is sorted. Now I have written these programs based on my value by sizes fixed like 5. You can ask the size from user as well. I have done this thing previously for you guys. Printf, enter the number of elements you want to enter. So I'll say scanf %d comma ampersand n, and I'll declare a variable here in 10. Here I'll say n here, and every 5 will be replaced by n. And here as well. So let me try to sort the elements, 10 elements. So 10, 50, 60, 20, 30, 40, 10, 80, 90, 70. So there you go, 10, 20, 20, 30, 40, 50, 60, 70, 80, 90. So the list is sorted. So this is the bubble sort program that I have done for you guys. Okay, so let's continue our programs. After bubble sort, let's talk about the 1D and 2D arrays. 1D represents one dimensional array and 2D represents two dimensional array. Okay, so what are 1D and 2D? The previous arrays that you have studied is 1D array that represents one dimensional array. Okay, for example, in the previous programs we have done this int a5. If we do this, an array from 0 to 4 is created with 5 elements that can be placed inside the array. Now we can pass two sizes in the array. First size will represent the row size and the second size will represent the column size. You guys might have studied in mathematics the matrices. In matrices, the elements are stored in form of rows and columns, and there is a row size as well as the column size. And the same thing can be done in the programs using C language or C++ language as well. So here in 2D array, I will pass two sizes which will represent two-dimensional array. For example, here I have passed int matrix. I have created an matrices array of matrix with two sizes 3 and 2. This 3 represents the row size and this 2 represents the column size. Okay, if you do this, something like this will be created for you guys. This is the matrix, this is the first row, second row, third row, and this is the first column and second column. But as you guys know that the counting starts from 0, so this is R0, R1 and R2, whereas this column is C0 and C1. Now these numbers represents the position in the matrix your element is placed at. So this is row 0 and column 0, so 0 0, and this is row 0 and column 1, so 0 1, and so on. 1 0, first row 0th column, first row first column, second row 0th column, and second row first column. Okay, so this is the way you can perform the programs related to matrices in the C language or any other C++ language. Okay, so let's write some programs related to matrices. First of all, a program to represent the matrix. Now your matrix looks like this: row 1, row 2, col 1, col 2. Now this I have placed the elements based on their position. So this is first row first column, so 1 1, first row second column 1 2, second row first column 2 1, and second row second column 2 2. The order of the matrix is written down here like two rows and two columns. If you want to write these programs in the programming language, I'll do this for you guys in the new file program. to represent the matrix. I'll start with header file, sorry for that, hash include diu.h. Then I'll say main function. I'll declare a matrices here like 3 by 3 or any other array like 3 2 or 2 1. To read the values of inside the matrices, you need two array loops I and j, and you have to put the nesting here. So I'll say printf enter the elements in 3 by 3 matrix. Okay, and just and I'll start a loop. My first loop will represent a row. So row loop, I'll start for I equals to 0 as the array starts from 0, I less than 3 because my row size is 3 here, and I'll say I plus plus. Inside this loop, I'll place a column loop. I'll say for j equals to 0, j less than 3. This is for column size here. 3 j plus plus, and inside this loop I'll ask the value from user. So scanf %d to read the integer value, and sign, and I'll say matrix I j. Okay, so this position will keep on changing. Okay, let me save the program here, and then I'll say printf slash n elements in the matrix. I'll copy this loop here, and I'll paste it here, and I'll convert this print scanf into printf, and remove this ampersand sign, and at the end I'll place a return 0. Let's see how it works. There you go, it's asking me the elements here. So 3 by 3, that is I have to place 9 elements here. So 11 22 33 44 55 77 88 99. Now elements are shown, but it is not in the form of matrix. As you see here, the elements are written in the matrix form. So how I'll do that, to put the gap between the elements, I'll place a /t in the printf statement. So I'll say, and at the end of each row there is a /n. So for this purpose I'll place a /n at the end of column loop. So /n for new line. Okay, let me end this file and rerun the program. So I'll say 10 20 sorry 30 40 50 60, whatever elements you can put. Now there you go, the elements are printed in form of matrix. I cannot place a line here because I don't know how to do that, but this is done here for you guys. Okay, so this is a program to represent the matrices in the programs. All right, so let's continue our slides and continue. Now the next program that you guys can do is program to print the transpose of the matrix. Now what is transpose? It is the opposite of original matrix, that is the elements written in row form is written in column form, and so on. So this row will be written in form of column. So the transpose of this above matrix will look like this one. So 11 and 12 written in row form will be written in column form 11 and 12, and so on for 21 and 22. So I hope you guys can do it by yourself. Otherwise I'll teach you if you ask me in the comments. Okay, the next program is to add two matrices. Now let's say you have these two matrices, and how will you add these elements? Okay, now matrices addition is simple. The first element is added with the first element of the second matrix, and the second element is added with the second element in the matrices. So something like this one. So 11 will be added with 11, that is 22. Then 12 plus 12 equals to 24. Then 21 plus 21 equals to 42. Then 22 plus 22 equals to 44. To implement this program, you will need three matrices. Okay, make sure that the matrices are of same size, that is either of 2 2 or 3 3 or 2 3 or 3 2. Okay, now after performing this program, you can continue your program of matrices multiplication. Now matrices multiplication is a difficult task to perform. If you have these two matrices, like so these two matrices, you first of all have to check that whether the matrices multiplication is possible or not. How's that? If number of columns in first matrix matches the number of rows in second matrix, only then multiplication is possible, otherwise multiplication is not possible. Once you have done this, your matrices, the resultant matrices of multiplication will have the remaining size, that is 2 by 2. Okay, the remaining size here and here. Okay, now how the multiplication will be performed? The element will be picked from first matrix row wise and from second matrix column wise. So 11 will be multiplied by 11, then we'll put a plus sign and we'll multiply the second element of row, that is 12, with the second element of column of second matrix, that is 21. So 11 multiplied by 11 and then 12 multiplied by 21 will result in 373. Then you will repeat this row of first matrix and multiply this same row with the second column of the matrices. So you will do 11 multiplied by 22 plus 12 multiplied by 25, which will result in 396, and so on for the next row. That this row will be multiplied with this column first and then with this column first. Okay, so the resultant matrix will look like this one. Okay, so after performing the multiplication, you guys can start with sum of all the diagonal elements like this one. So if you have a square matrix of 3 by 3, you can add 11 with 22 with 33, that is in this form, and your resultant answer should be look like 56. Okay, the next program is little bit difficult program to find the determinant of the matrices. How to calculate the determinant? I have done this for you guys. Now I have used a matrices of 3 by 3. The determinant can only be calculated of square matrix, that is of 1 by 1, 2 by 2 or 3 by 3. Here I have solved equation 3 by 3 for you guys. You can implement this thing by yourself. Okay, how this is performed? We have picked the first element 1 and put a sign plus here. Then remove this column and this row, and the remaining matrices is picked. We continue the same with the next row, that is 2, put a sign minus there and again remove these elements. Then so now these elements are multiplied like this one, 6 multiplied by 2, 12 minus 14 multiplied by 9, 126. Then so on, minus 3 multiplied by 2, 6, minus 11 multiplied by 9, 99, and so on. Okay, after calculating this, we have subtracted this value. So 12 minus 126 equals to minus 114. Then same for this 105, and this same for this 108. Then we have multiplied this value with this. So 3 multiplied by 108 equals to 324. Again 105 multiplied by 2, 210, 114 multiplied by 1 minus 114, and we put the sign according to the math rules. Then we have solved this and our answer is minus 228. So you guys can perform this determinant matrices as well. That's it from this video. Thank you for watching my YouTube channel. Keep on subscribing and sharing my videos. Thank you very much. See you in the next video. Cheers.